This is managing machine learning projects, final project submission for Sean Ryman. This artifact is part of the final project submission. This video is to hit the highlights of this artifact and create the summary. Problem that I'm focusing on here is for inbound supply chain planners having difficulty inaccurately predicting when inbound shipments will arrive at a e-commerce fulfillment center. This is a broad problem across this industry with importing products from Southeast Asia and other countries, being able to make sure that things are arriving on time so that downstream supply chain constituents are able to plan for the right amount of labor, the right amount of storage capacity, so the products can move smoothly through. When this doesn't happen, sellers, suppliers have churn because their inventory is tied up on the dock and not available for sale, excess costs for overtime, inefficient labor when products don't show up. Poor customer experience really is the end result when things aren't available and people can't buy products and get them on time. So due to the company-wide impact, this is going to be a major cost item for the organization's P&L. Very important to C-suite and shareholders, so there are a number of people that are concerned about solving this. This is a prediction problem with many possible features, also has generally available data. We're going to explore using machine learning to improve the accuracy and automate this area. Below is the ChrisDM template that I filled out for this. Again, the problem statement is inbound accuracy. We've already talked about why it matters. Today, users generally use heuristics to come up with these. As far as constraints go, some of the data is input by humans as things go through the process. There's also a lot of choppy historical data with hurricanes, pirates, other shocks to the system. Some of the outcome and output metrics here are accuracy, receive SLA, and then from more of a statistics perspective on the output side, MAPE, R squared, and then looking at RMSE to test for model volatility or outliers. Definitely in this area, we would want to speak with domain experts to make sure we understand all the factors and things that need to be included as features in the model. Understanding when things happened and how we should label that data is also going to be important. From a validation plan perspective, there's already a lot of good heuristics out there, so the baseline for accuracy should be available. And the goal would be to beat that level of accuracy and then improve the amount of automation for those teams. Below steps are the ones that were of most interest. So from a data understanding perspective, after engaging with the domain experts, collect the data, analyze it for outliers, test for correlation. Some of these things will be extreme, so we need to figure out how to label that data. From a modeling perspective, we would begin by adding all of the features into the model and then testing for accuracy and iterating through what things were relevant and what things weren't. Due to the nature of the shocks, I would want to go and validate the model on validation data and test data against times when these shocks were happening to see how durable the model was at predicting issues during these times. These are times when it's really critical to have a model like this, because otherwise humans will result to human judgment, which may have poor outcomes. From a system design perspective, when looking at cloud versus edge, this is clearly more of a cloud processing issue. Timeliness of decision making is relatively slow. From a computation perspective, doing this in the cloud would definitely be sufficient and doesn't need to be done on a device. Offline versus online learning, having a system where learning is done offline, potentially weekly or daily, would be sufficient for this solution. Batch versus online predictions. Predictions do I need online? We do need online predictions. This is mostly an event-driven system. And so what that means is every time there's a new piece of information, you want to get a new prediction, because as you get closer to the delivery, the conditions could change and you want to be aware of that and have an update. As far as potential risks in production go, things like the Suez Canal blockage, labor strikes, pirate attacks. These could create a number of issues. They're hard to predict, and so having this in training could create training serving skew issue if not addressed in labeling the data correctly. Uh, Also, the model definitely need to be constantly retrained and data correctly labeled. Input and output monitoring would need to be essential and will be necessary to provide feedback loops to the operators to gain trust.